Hey everyone, and welcome back. And we're gonna keep doing the chapter 4 polynomial equations and chapter 4D. We're gonna learn something called reminder theorem and quotient theorem, I think. Yeah. And first thing first, let's start with some examples actually. So if you had a polynomials like px and then polynomial dx, and they have two polynomials, and you could do the quotient and reminder and such as like to create your new polynomials like that. And also like 'cause, if the polynomial actually divided by the dx, and you can find the divisor. So how that actually means, and I will show you some like examples. So we're gonna using the long division. So first thing first, divide by 3 is divide 3 is our x cubed plus x squared minus 14x and minus 24 by x plus 2. So we could do is we could do the long division theorem, which is x cubed plus x squared minus 14x minus 24 and x plus 2. So first thing first, let's try to so do the different leading terms and stuff. So start with like x cubed. So let's think about uh, how we can actually cancel out the x cubed in the first division. So we could do is so x plus 2 times some x, and that equal to x cubed something. So we choose x squared. So because x squared times x equal to x cubed. And plus 2 times x squared, so it's 2 times x squared. And make sure there's a minus in front. And that's my first level. And you can say x cubed cancel out, and x squared minus 2x, which is the minus x squared, and minus 14x. So now we have a second level. Now some term times x plus 2 equal to some negative x squared. So because that's a negative, so we're using minus x, because minus x times x equal to minus x squared and minus 2x. And remember, you have a minus in front, that's why you get a bracket. And minus 14 plus 2x, which is minus 12x, and x squared are cancelled out. And minus 12x minus 24. And because that's minus 12x, so x plus 2 times something equal to minus 12x. That could be minus 12. So there you go, minus 12 times x minus 12x, not 70, minus 12x, and minus 24. And you can say, if I say minus in front, that become to 0. So your reminder become to 0. And then we could rewrite as x squared minus x and minus 12. That is your divisor. So redo a little bit. So x cubed plus x squared minus 14x minus 24 divided by x plus 2 equal to x squared minus x minus 12. There you go. Does that make sense for everyone? If not, try to go through again about long division, and then let me know during the class, okay? So now we have another one, it's a quartic. So we could do this one during the class and leave that one for you guys to do. Okay, so please have a look at it and try to practice by yourself, and we keep going. Sometimes we can actually using the CAS calculator during the exam too. This one, I will show you how to do it during the class as well. So make sure follow the step, and you'll be able to figure out. All right. Um, Now we're gonna go some of the increasing coefficients. You can see you can see the second methods, which is the called increasing coefficients, and called saying the explanations column of the next example. Let's have a look. So first thing, long division, as always. 3x cubed minus 2x squared plus 3x minus 4 and x squared minus 1. Perfect. And then we're gonna have that because first thing is x squared minus 1. That's your divisor. So we could do is 3x and 3x times x squared equal to 3x cubed minus 3x. All right. And because there's no x squared in between, so we could move that one down the bottom straight away. And this one, 3x and negative 3x, will become to plus 3x, which has become to 6x plus 6x. And we keep going, and that's minus 2. So minus 2x squared plus 2. So we can say that become to 6x and minus 2, minus 4 is minus 6. And that's it. You can't go further because it's already below to the x squared, so that's only 1x. So we could become to 3x minus 2 plus, make sure it's plus, your remainder right down on top of the fraction, and down the bottom is still the x squared minus 1. And that is your final answer. So please make sure you know this one, and in next video we're gonna keep doing to tell you what is the remainder theorem looks like.